Hello, everyone. It's really my pleasure to introduce you our project. I'm Xiangliang Zhang. I'm the PI of this KN Wildlife project. So this tutorial is prepared by me and my students Xiangqi and Ethan from our project, and Jason is the supervisor of Ethan. So we are a group of computer scientists and biologists, ecologists. So we are working together for this very exciting project. You can see our logo here. We are targeting on building a knowledge network for wildlife. And our project is sponsored by NSF Proto-OKN program. And it is a great program including different kind of knowledge network. And today, please follow me to see what we are building for the wildlife. So the motivation, the background of our project is when we were working with biologists and ecologists, we found that they were struggling to get data across segmented and heterogeneous data resources. So for example, they can find very useful data in USGS or GBIF or other websites, but they are not standardized and it's not that easy for them to collect all the data they need. For example, to predict the species distribution in the future and study how species are affected by different climate environment factors. So in computer science field, we have been seeing how knowledge network is connecting different type of data and the relevant concept and making the information be more searchable and accessible. So that's a motivation that we want to build this knowledge network that can connect relevant concepts and present more information about the species for scientists to study. So in our project, we have three aims. So the first aim is we want to build the network because the knowledge network is very useful, as I said earlier, but it's not that ready. So we searched in the different kind of repository and websites, internet resources. So we extract these species observation records and also their properties and environmental related data, and then we link them and build a knowledge network. And the second aim is once we have the network, we have to make it be usable. So in other words, the people, including researchers and the public and the wildlife managers, and also people from different research area and also in different departments, so they can use the network easily. For example, they can send queries and they can have interactive operation with the graph. So that's why we build a portal system that will be introduced by Ethan. And we have the knowledge graph as a backbone for supporting these interactive queries and interactions. And the third aim is, of course, we want to support the species distribution prediction. So by using our network and our portal system, scientists can download the data set and then run their model to do the prediction and to do the analysis. So the portal system is here. As you can see, it's ready to use. So please feel free to use the link provided here and try different kind of queries and visualize the results on the map, knowledge graph, and you can even download the data as a table data. So this is already provided by Ethan for the tutorial regarding how to use how to use a portal system and how to build a portal system. And next, I want to invite my student Xiangqi to talk more about the knowledge graph, how the knowledge graph looks like and how we build the knowledge graph. Thank you.
Yeah, and as for the knowledge graph for its specific details and techniques, here is an example of how a knowledge graph is constructed. As we can see, in Louisiana and San Bernardino County, we can have multiple observation sites. For example, like Arabi Energy Power Station, which is calculated based on the geolocations. And for each specific observation site, we can have multiple observations of different specific species. And for each species, we can also create a specific species node, like a green tree frog as revealed in the slide. And the knowledge graph can be in this structure integrating the site, species, and also various public information sources. Like for example, for this one, this is from a naturalist, but we can also cover more different ones, like from the EPA dataset, and we can also incorporate other knowledge graphs into this can wildlife, and currently is available in Neo4j format, which is a publicly accepted platform to store the knowledge graph, and is currently available online on cloud with credentials provided upon request. And for the statistics of KN wildlife, as is observation records, we have 340,000. And for the species nodes, we cover 2,000, including the fish, amphibian, reptile, and birds. And for each species is classified as a specific genus, which is 500. And for the county nodes, we cover the whole nation, including 7,900 counties. And for the side node, which can be multiple within each county, we have 10,000 for the side node. And uh, this is example as the previous one, but as we can see, the Helia, which is green tree frog, it belongs to the Trophy genus, and it belongs to Helidia family, and Anura, like tax class, and then it's Amphibia, which is a general class. And the sources we are collecting the animal observations mainly currently from JBF and naturalist, but it can also be extendable to other ecology-specific datasets. For example, like the United States Environmental Protection Agencies. And for each observation site, we can enhance it with the open weather geoclimate collection data, which is available publicly and onlinely from this website. And for each like bizarre scientific names, they can be standardized by Wikidata ID, and they can also be enhanced by the GeoSparkle queries. And as for the scalable ontology, for this framework, we can better support ecological researchers. In this framework, as it's stated on the right, the center node is observations node as stated by Ethan, and each observation node can be observed in a certain site, belong to a certain county within a certain state, and collected from some data set. We can also connect it with some scientific publications. And the observation node, we can link it to the species and this scientific classification genus. And so with this structure, we can make it extendable to the new sampling events and new species by crowdsourcing or by the scientific datasets. And it also supports the use of multiple APIs, which support automatic data collection tools and other graph connections. And it is easy to extend include more datasets, such as the extra densified one or the more ecologist monitoring records. But the currently one is mainly about the GBF and naturalist. And as for the kernels and edges, we can provide some examples of how they are detailedly recorded. Currently, the left node is observation set. For each node, we can see the API URL attribute, which record the temperature and precipitation data. And it also records its Wikidata ID and its JBI coordinates. For example, it's recorded in New York, Johnston, which is a certain location, and the site is named in such format. And the observation edges, which is another key attribute, is like what species recorded in this location. And we can also see how many times it's recorded and the coordinates and the multimedia information recorded in its attribute. And the example is the same as the previous one. And feel free to contact us if you are interested in our project, and where our group member involves Dr. Xiangliang, Dr. Jason, Xiangqi, which is me, and also contact Ethan Brown for any question about the user portal.